Welcome to Study Loop.
Hello everyone, today we're doing chapter 17, problem 54, and this problem asks us which of the diethylbenzene isomers, ortho, meta, or para, correspond to each of the carbon-13 NMR spectral data shown here. So what we need to do is first draw the three isomers of diethylbenzene. So let's first draw those out. And now we have one ethyl group, so we'll have the ortho substituted right next to it. And then we'll have this one ethyl group arbitrarily at carbon number 1. Then we'll have the meta substituted. And then we'll have the para substituted. So now let's determine the different types of carbons in each one of these and then compare it to the spectral data here. So in A, we see we have 1, 2, 3, 4, 5, 6 carbon types. In B, we have 2, 4, 5 carbon types. And in C, we have 4 carbon types. So let's keep that in mind while we analyze this information. So determine the different types of chemically distinct carbons in each of these isomers. We need to determine if there's any internal plane of symmetry. So right off the bat, we see an internal plane of symmetry of this one down the middle here. So what's true on one side will be true on the other side. So we know that this is one type of carbon. This is the second type of carbon. This is going to be the third type of carbon. This is the fourth type of carbon. And this is the fifth type of carbon. So these are 5 chemically distinct types of carbons. So we know that this is going to be spectral B. Well, now, what about the structure here? So here we also have an internal plane of symmetry, but it goes down like this through 2 carbon atoms. So here what we see is that, remember what happens on one side is true on the other. So once again, this is carbon type 1. Then we have carbon type 2. We have carbon type 3. Carbon type 4. But now we have this carbon, which is 5. And then the last carbon here on the plane of the internal plane of symmetry, carbon 6. So these are chemically distinct environments. So we have 6 types of carbon. So this is actually A. And we know that 5 and 6 are different because 5 is bound to carbon and carbon that are bound to one hydrogen, one other carbon, while 6 is bound to a carbon-carbon, but these carbons are now bound to an ethyl group each. So we know that 5 and 6 are in chemically distinct electronic environments. So now, if you look at this isomer, and actually, if I were to draw this one better, so if I were to draw this isomer better, and if I were actually to rotate it like this, then we see that we actually have an internal plane of symmetry that goes 2 internal planes of symmetry. One that goes down the middle like this, and then one that goes through those 2 ethyl bonds like this. So you have 2 internal planes of symmetry. So what does that mean? Well, that means that what's true on one side will be true in all other quadrants. So for example, this carbon type, this carbon type, this carbon type, this carbon type are all one type. This carbon type and this carbon type will be type 2. This carbon type and this carbon type, type 3. Then those terminal methyl groups will be type 4. So this has 4 different types of carbons, so we see that this is type C.